Okay, this video we're going to talk about this topic called simple lifting machine. Okay, so there are two keywords here, lifting and machine. Okay, back in primary school days, you must have picked up this in science, simple machine, right? So you have the pulley lah, lever lah, all these they are supposed to help you do work. Okay, so in that case this is also true for this topic lah. Okay, the other one keyword is lifting, means you have to in simple terms in the simple form, let's look at this. There's a pulley here. Okay, you have to put in an effort to lift the load up. Okay, so the load is going to go up. So how we define is the load is a W. Okay, and the effort, the force that the downward force that you apply to pull this cable, right? I would say a cable is the effort is called E lah, E for effort. Okay, so this one is supposed to be a machine, which means it's supposed to help you. All right, so if it's supposed to help, by right, you wouldn't be spending an effort that is more than your load, or else you just manually carry it. Isn't it easier? Correct. So by right, this machine has an advantage. Okay, and it is called the mechanical advantage. Okay, in short, it's called MA. Okay, so by right, this advantage means that your effort must be less than your load. Okay, like I say, you might as well use your hand to carry, right? So typically this value, our load will be bigger, right? So this value should be more than 1. Okay, so this is one equation, one formula for this topic, mechanical advantage. What is the advantage? Okay, the other one is the velocity ratio. Okay, velocity ratio, so we call it VR. Okay, to put it simply, imagine when you pull this, use your effort to pull this down, right? How much distance do you travel, okay, to pull this thing down? Okay, this one is the distance traveled by your effort, so we call it XE. Okay, versus how much distance did the load go up? Okay, so this distance we call it XW. Of course, if you look at a simple pulley, then by right these two should be the same lah. But let's say when we talk about something like a crab winch, okay, then the situation will be different. Okay, you will find that the effort actually travels a larger distance than the load distance. Okay, so in that case, the velocity ratio is actually the how much effort you have pulled, the distance that you have covered over how much distance the load has covered. Okay, XW, XE over XW. Okay, then the next question you'll be asking is, then why is it called the velocity ratio? Very simple. Imagine you pull this down and this load goes up, correct? And you take some time, let's say delta T. Okay, delta T to pull this down and delta T to go up, right? So by right, these two time taken should be the same, right? And if I put this delta T inside both the X, you will get what do you get? You will actually get velocity. Okay, velocity at the effort side over velocity at the load side. Okay, that's why the formula is called the velocity ratio. So both are applicable. Okay, VR is equals to XE over XW. VR is also equals to VE over VW. Okay, now one thing I want to highlight about this VR is this. It is very much dependent on the design of the machine. Okay, it's only depend. Okay, so what I'm trying to say is VR depends on the design of the machine. Okay, if my gears if my gear teeth, if my gears that I use over here don't change, if the diameter that I use here don't change, right, VR will remain the same. Okay, it also means that VR, right, is independent of either your effort or your load. Okay, it doesn't mean if I increase my effort or increase my load, VR will change. VR will always remain the same as long as the design remains the same. Okay, so this is very important because later on during your questions, okay, if you fail to appreciate this fact, and you will go and use the wrong formulas. Okay, now, okay, of course, being engineers, we are also interested in this thing called efficiency. Okay, efficiency. Okay, this means that how much work is being produced, what is the work output over how much input that you put in. Okay, so basically we are talking about work output over work input. Okay, now this one, efficiency is always going to be less than 100%. Okay, because by law of nature there's going to be losses. Okay, and because of these losses, that whatever they put in will never be the same as whatever that it produces. It will always be higher than the output. Okay, that's why efficiency will always be less than 100%. Okay, now output, what do we see as output? If you look at the simple machine, which side is the output? It will be the load side. Okay, because effort side is where you input your work, right? So the output will be shown at the load side. Okay, so when we look at the load side output, work is force times distance. Correct? Work is force times distance. So in that case, work output is basically what force are we looking at the load side? It will be W, no? Then the distance will be XW. Okay, so work output is force times distance. Okay, and then the input will be your effort side, force times distance. Okay, and if you carefully examine, you find that this is actually your MA. Okay, and this one is actually belong to your velocity ratio. Okay, so efficiency is actually MA over VR. Okay, so with MA and VR, you will be able to find efficiency. Now, efficiency will depend on how much load and how much effort. Okay, just like a mechanical advantage, it will change. Mechanical advantage will change depending on the load and effort. Okay, the only thing that is independent is your VR. Okay, just to refresh your memory here. All right, and one more thing is if our efficiency is 100%, okay, this is where we have an ideal effort, which means this effort is so ideal that it gives you efficiency of 100%. Okay, and if you look at this efficiency 100%, okay, it means the left hand side is 1.0. 1 is equals to efficiency is 1. Okay, then this side will be W over E, right? Ideal effort law. Okay, W over E over VR. Okay, so the equation that you can derive is just then ideal effort equals to W over VR. Okay, this one is the ideal effort. Imagine if you pull a pulley, what will be the ideal situation? Okay, it will be when there's no losses, right? So when there's no losses, what does it mean? There is no friction in this pulley. Okay, it means that my friction, we call it EF, friction effort, is 0. Okay, Now the total E, the actual E, the actual effort will then be ideal effort plus friction effort. Okay, and this will always be the case. Okay, that's why in your lecture notes there is a section where this is the graph that this is the total E. Okay, it is made up of ideal plus friction. Okay, so this plus this plus this will give you this. Okay, that's the idea. All right. And we want to talk about something that's related. There is the law of the machine. Okay, law of the machine goes like this. If you plot your effort against your load, okay, so again I bring back to the case of the pulley. The more load you have, of course, naturally the more effort you need, right? Okay, so the law states that there is a linear relationship. Okay, there's a linear relationship. As your load increases, your effort will increase. Okay, and when there is no load, right, you will realize that it's still an effort that is required. Why is that? Why is it so? Because even there is no load, you still need to overcome the friction effort. Okay, so this y-intercept, right, is your friction effort. Okay, when the load is 0. Okay, and like all straight line equations, it can always be expressed in y equals to mx plus c. Correct. So the equation for this case is E is equals to a w plus b. Okay, so this b would be the friction effort, which is the y-intercept. W is the x-axis. A would be the gradient of this line. Okay, the gradient of this line. This is the m. Okay, so A would be the m, the gradient of this line. Okay, so this is what we call the law of the machine. Okay. Okay. Last but not least, we also can look at another graph that is talking about the relationship between another thing. Okay, let me see. It is also load. Okay, as your load increase, we look at mechanical advantage. Okay, the nature of mechanical advantage is such that as your load increases, right, the mechanical advantage will actually increase steadily. Okay, but it will not increase like this for infinite lah, because machines are machines. Okay, they are limited, so you won't have infinite advantage. So what will happen is it will gradually decrease. It will gradually drop in the rate and go towards a certain value. Okay, go towards a certain value, and we call this the limiting mechanical advantage, this value here. Okay, what is this MA limit? Okay, and likewise, if you look at the efficiency of the machine, okay, let's plot a secondary y-axis here and call this efficiency. It also follows a same nature. As your load increases, the machine will give you a higher and higher efficiency. Okay, so it will increase also. It will increase also, but it will also go slowly reach a certain value. Okay, it can never go, of course, all of us know that it can never hit above 100%, right? So it will always hit a certain max out lah. It will max out at a certain value. So this one is your limit efficiency. Okay, that's how you describe this lah. Okay, and of course there are formulas that are related to these two values. Okay, MA limit is actually related to the law of the machine, 1 over A. Okay, this A is the gradient of this line. 1 over A will be the limit of the mechanical advantage, and limit of the efficiency, right, you can actually find the value as 1 over A times the velocity ratio. Okay, so all these formulas you will know and make use of these formulas lah. Okay, if you don't appreciate, right, you will find it harder to apply these formulas. All right, now let's look at one example. Okay, 4.3. This video is going to be fairly long because I introduced the tutorial question. Okay, tutorial 4.3. In case the question next time changes in the numbering, this is the tutorial that I'm talking about. Okay, lifting machine have velocity ratio of 35. Okay, this is the tutorial. Now let's look at it. Velocity ratio given as 35. Okay, so this is the design of the machine. It won't change, okay, unless the design changes. All right, and then it tells you that when the load, 36, when the effort is 36 Newton, right, the load is 550 Newton. Okay, this is one point where one point here. So let's say this is the value when your load is 550. The E, right, the E here is actually 36. Okay, so I need 36 to lift up 550. Pretty good, pretty good advantage. Okay, so this is one point, right? So we will name this E1 and W1. Okay, then it gives you another point. Effort, second point, I need 100 Newton. Okay, to lift a load of 2,400 Newton. Okay, 2.4 kilonewton. Let's change to 2,400 Newton. Okay. Then you can find the law of the machine already, because you have 2 points. Okay, you have 1 point, you have another point here. Okay, using 2 points you can find the unknowns A and B. Okay, simultaneous equation. So E equals to AW plus B, right? So you just substitute 1 point. 36 is 550A plus B. This equation 1. Okay, 100 is equals to 2,400A plus B. This is equation 2. Okay, so simultaneous equation, I will subtract 1 from the other. I'll subtract 2 minus 1, I can cancel B. Okay, so 2 minus 1, I will get how much? 2400 minus 550. Okay, 1850. And the left hand side, I will get 64. Okay, 1850A. So A is 0.0346. Okay, and after you find A, you can find B. Okay, so B will be your 16.97. Okay, so your law of the machine is E is equals to 0.0346 W plus 16.97. All right. Okay, one thing to note is the question may not so nice give you everything in Newton. This question is good because it gives you in Newton. Okay, he may tell you Okay, you need 36 Newton to carry a load of 50 kilogram. Okay, so sometimes it's not Newton anymore. The load is telling you is in kilogram. So in that case, right, you have to convert the load using W is equals to mg. Okay, mass times gravity. So the load is 50 times 9.81. Okay, then you have to use this as your W1. Okay, so this is just for example. Be careful. You have to look at the units that is given to you. Is it Newton or kilogram? Okay. Okay, part B, mechanical advantage when the load is... So since you already have your equation, right? Okay. Load is 1500 Newton. Okay. So I can use the law of the machine to find the effort. Okay. You will get 68.87 Newton. Okay, and from there you can also get mechanical advantage because it's W over E. Okay, W over E, you get 21.78. Okay, and efficiency you can also find because it is MA over VR. Okay, VR is already given 35. So this would be 0.6223, all right, or 62.23%. Okay, so this would be a very standard format of the question. The last part is quite similar, is usually similar. So the last part is always to ask you to find power. Okay, power is force times velocity. Okay, power, the formula for power is force times velocity. But what force and what velocity are we talking about? If you look at the question, it says power required. Okay, the keyword is required. So it means what? The power that the machine need from you. Okay, how much do you need to put in? Okay, it means a power input. Okay, power required means power input. Okay, and when we say input, it means your effort side, not the load side. Okay, it's the effort side. So effort side, what force is the effort? Means E lah. Okay, then the velocity at the effort side is velocity lah, effort velocity lah. Okay, so these are the two things that you need to put in. Okay, and you already have the effort when load is 1500. This is your effort, you already found. Okay, so you can use this value. Okay, now the problem here is now to find the velocity at the effort side. Okay, and the question will almost never give you direct. Okay, instead the question will give you the other velocity, okay, which is your load velocity. VW is 45 mm per second. Okay, when you raise the load at 45 mm means the velocity of the load is 45 mm per second. Okay, so first of all, let me convert to meter per second first. 0.045 meter per second. Okay, so this is your VW. You still need to get VE. Okay, now how to get VE? Of course, we have what we call the velocity ratio. Okay, 35, and this one is VE over VW. Okay, so therefore I can find my VE, which is 35 times VW, okay, which is 0.045. Okay, so you will find that your velocity, effort velocity, is actually moving much faster, 1.757 meters per second. Now we can put into the power equation. Okay, so power input is equals to 68.87 times 1.575. So this will give you 108.5 watts. Okay, so that's the typical question for simple lifting machine.